This is the first in a series of videos designed to help you provide the highest quality service to your customers. The purpose of this videotape is to review the need for insulation, how insulation works, the types of insulation available to the contractor, and their applications. Owens Corning has been producing and providing a wide variety of glass fiber insulation products to the building construction industry for over 60 years. They've been installed in millions of residential, commercial, institutional, industrial, and other buildings. In every case, the insulation was there to provide a comfortable living and/or working environment by controlling both the temperature and noise in the occupied space. Insulation's principal function is to slow the rate of heat flow. Energy in the form of heat always moves from an area of higher temperature to an area of lower temperature. This movement is slowed if the heat must pass through a sealed or dead airspace. Glass fiber insulation works even better by trapping the air in billions of tiny pockets, breaking up the heat flow path through that space. In the heating season, when temperatures are colder outside the building, insulation provides a thermal envelope to preserve the heat inside the occupied space. In the same way, during the cooling season, insulation is equally effective in keeping the hot air outside the building. The ability of insulation to slow down or resist the flow of heat energy is expressed as its R value. The higher the R value, the greater the insulating power. Just as insulation provides a thermal blanket around occupied spaces, it also dampens the transfer of noise or unwanted sound, both between the exterior and interior of a building, as well as between rooms within the building. Sound travels in waves, both airborne pressure and structure-borne vibration. Glass fiber insulation placed in the cavities of framed walls provides a similar type of resistance to sound transfer. Again, the many tiny pockets break up airborne pathways, diffusing the sound. The ability of insulation to reduce sound transmission is expressed as its noise reduction coefficient, or NRC. As with R value, the higher the NRC means greater reduction of sound transmission. Since the other materials in a wall assembly affect the acoustic performance of the whole wall, another unit of measure is used to express that overall performance. Specifiers often require a minimum sound transmission class, STC, for the wall assembly rather than an NRC for each individual component. There are other issues in building construction that impact the performance of the insulation system, but are not a function or property of the insulation itself. These include such things as moisture accumulation, ventilation, and air leakage. Moisture generated by various sources within the building is generally trying to move through the thermal envelope to get outside. Under the right conditions, this moisture may collect within the wall, ceiling, or floor assemblies, causing material and structural damage and potential health concerns. This is usually controlled by the use of a water vapor retarder, a material that may either be separate from or integral with the insulation. Another technique for controlling moisture is ventilation of the unconditioned spaces that are adjacent to the conditioned areas in the building, notably attics and crawl spaces. Venting these areas draws off the water vapor that migrates through the assemblies from the living areas, reducing the chances of condensation. Note that in locations with prolonged periods of high heat and humidity, neither vapor retarders nor ventilation may be effective. Always consult your local building official for applicable code requirements. A third issue that affects insulation is air leakage. Movement of unconditioned outside air to the inside, infiltration, or loss of interior conditioned air to the outside, exfiltration. Both heat energy and moisture travel with this air movement. Thus, air leakage promotes heat loss and gain, as well as excess moisture, affecting occupant comfort and putting additional loads on the heating and cooling system. Fiberglass building insulation is available in two primary forms. First, batts and rolls. pieces of insulation made to specific dimensions. And second, loose fill, small nodules or chunks of fibers. The standard specifications to which building insulations must comply are ASTM C665 for blanket and ASTM C764 for loose fill. These standards establish material classifications as well as describing tests and setting limits for physical properties such as thermal resistance, flammability, water vapor absorption, corrosiveness, and fungi resistance. Fiberglass blanket insulation is produced either as bats, pre-cut lengths that fit conventional framing cavities, or in roll form, longer pieces which are fabricated and cut to a desired length by the installer on site. Blanket insulation comes either unfaced, just like the fiberglass itself, or with facing of craft paper, foil, vinyl, or other material. The primary function of the facing is to provide a water vapor retarder for moisture control, as we previously discussed. A secondary function of the facing is to provide a protective covering when the application will be left exposed, for example, a basement blanket. Note that standard craft paper and foil facings are combustible and cannot be left exposed. They are marked with a warning statement and must be installed in substantial contact with an approved ignition barrier, such as gypsum wallboard. The facing is usually attached to the insulation with a light coating of asphalt or a very thin layer of polyethylene, which melts during the curing process. Either adhesive method provides a bond strong enough for a stapled insulation, yet will release with very little damage if the facing needs to be removed. Fiberglass loose-fill insulators are produced in either bonded form, where the glass fibers are held together by a resinous glue or binder, or unbonded, where no binder is required. Loose-fill insulations need special equipment for installation, but require no on-site fabrication. They are applied either in open blow applications, such as attic floors, or closed cavity applications, walls, or cathedral ceilings. Before we begin the individual installation modules, we would like to share a few tips for you to keep in mind. These are some ideas that we picked up from many of the contractors we worked with in developing this series. First, if you open your bat bags carefully, you can use them as trash bags. Simply slit the edges and peel back the bag, then staple them to the wall. You can throw trash into the bag for easy disposal at the end of the day, or you can use them to save small leftover pieces and take them back to the shop for use on the next job. Another good idea is to have a checklist to review at the end of each job. You might want to include a listing of the most frequent reasons for callbacks and check for all those items before you leave the job site. And with bonus rooms over garages becoming standard, one way to improve the comfort of those rooms is to use pink wrap in the garage ceiling to reduce air infiltration. This is an opportunity to improve the quality of the finished job and could even be sold as an upgrade. The 5 additional modules in this series will give you all the information you need to install a variety of Owens Corning products effectively and to maximize their insulation value for your customers.